Today we are talking about scientific notation. Okay, scientific notation is a way for us to write numbers that are really big or really small, just concisely. Okay, it's not always going to be the easiest way to write the number, but you see it a lot of times in science when they're talking about the size of an atom or how far the sun is and things like that. You see numbers written like this because no one wants to write out 36 zeros in front of something when they could just write it like this. We're not going to deal with numbers that big, but the same rules apply. So once you know how to do it one way, you can do it for all of them. So like I said, scientific notation is actually, before we get into these notes, you can get on your binder and you can take notes on there. This slideshow that we're about to, this page of this slide that we're about to go through is from this Google slide that I have on your journal. As long as you haven't deleted that, it's the last page on there, so you do have these notes. But if I say anything that you're just like, man, I really need to write that down, put that on your site so that you can come back to that later. Anyway, scientific notation is a way for us to write very large and very small numbers just a little more concisely. Okay, as far as vocabulary, you get the word coefficient. Okay, a coefficient would be like this 4 right here. Okay, whatever's in the front is going to be the coefficient. It must be more than 1 and less than 9. So it has to be a single digit number. And that's where people get messed up a lot of times. Just scientific notation is really, really easy, or you're totally wrong. Okay, if it's not easy, then you're not following the rules, and the rules are pretty simple once you learn them, but until then, if you don't follow them, you do get it wrong. A base is the 10. Okay, the 10 is referred to as a base. It's whatever we're multiplying by. The exponent is the little superscript number up here. Okay, that would be the exponent. There can only be one digit in front of the decimal. This is where we get into the rules I was just talking about. One digit in front of the decimal. These two numbers right here on this example, these two numbers come out to the exact same thing if you put them in your calculator. But one of them is in scientific notation and the other is not. It is just simply a math problem. Okay, it's got two numbers in front of the decimal, which is not how we do scientific notation. So that's not how we do scientific notation. That can't be the right answer. You'd be surprised. That little trick right there, knowing there's only two numbers in scientific notation, will mark out a lot of answers for you on a multiple choice test. Probably mark out two answers just knowing that right there. And then you can come back to the single digit ones and figure it out from there. The number after the decimal must include everything through the last non-zero digit. So on this example, we could get rid of these two zeros at the end, but those two zeros in the middle right there have to stay because those are placeholders. We don't want it to become 1,320,000 if we move that 3 and that 2 over. We want it to stay 1,003,200. So you'd write it as 1.0032 because you still got to have that 32, but we can get rid of these last two zeros right here. And then we would have moved the decimal 1, 2, 3, 4, 5, 6 places to get it where that 1 is our one digit in front of the decimal. So it'd be 10 to the 6th power. That's where that 6 comes from, is how many places you move the decimal. Now, when you're going from scientific notation back to standard notation, if the exponent is positive, then your number is going to get bigger. You're going to move your decimal to the right. If your exponent is negative, then your number gets smaller, which means you're moving it to the left. That just kind of tells you how to do that. And the reverse is true if you're going to scientific notation. If you move it to the right, then you get a negative. If you move it to the left, you get a positive. So that is how that all works out. Now, what you have to do today, if you have not already done it, is you need to go to Google Classroom and you need to watch the Edpuzzle video that I shared with you. That guy just explains it a little bit more, and there's some questions you need to answer on that. And then you can go back to your Google Classroom again, go to the scientific notation assignment that I shared with you. It has a link to IXL. When you get done with your IXL and you've done the maximum number of questions it'll allow you to do in a day, it'll tell you that your daily practice limit has been reached. This isn't going to load. Oh, there it is. It'll either pop up and tell you, or it'll tell you right here that your daily practice limit has been reached. Screenshot that, get your SMART score in it if you have one, and then you can upload that here. Notice it doesn't have any point values because that's just for practice. And then these 5 questions here are what you're going to actually answer to get a grade for the day. So if you get all that done, then you are finished. If you have any questions, feel free to come talk to me, or not come talk to me, but feel free to talk to me whatever way works best for you. You can message me, email me, however it works. Good luck, and let me know if I can help you.